Okay, so on this problem, these problems we're actually taking another look at base numbers, and what we're doing this time is taking a base 10 number and making it a different base. And this is a little bit harder, and the best way to do this is to use a division algorithm for it. And what I mean by a division algorithm is to take whatever base we're going to do. So in this first problem it says convert base 24 to base 9, or not, convert 24 to base 9. Well, if you remember, the way that you do bases is we group things together. So the first thing is we look for what is the greatest power of 9 that goes into 24. Well, that's pretty easy to see that the greatest power of 9 that goes into 24 is just 9. So the question is, how many 9s do I have in 24? Well, in this case, so I just do division. I divide 24 into 9, or 9 by 24 by 9, and I get 2. And so that means I have 2 9s inside 24. So my, what would be called the 9th digit would be 2. Then my remainder is 6. And so how many 1s do I have? Well, I have 6. So 24 in base 9 is actually 26. So 24 base 10 is equivalent or equal to 26 base 9. If I look at the 5s, well, the highest power of 5 that goes into 24 is just 5. And 5 goes into 24, because 25 is the next power of 5, and that doesn't go obviously go into 24. So 5 goes into 24 just 4 times, and I have remainder 4. So the 10, the fifth place, you've got 4 5s, and then 4 1s. So 24 base 10 is the same as 44 base 5. Now 3s is a little harder because we now are looking at the highest power of 3 that goes into 24 is no longer 3, it's 3 squared. Okay, and 3 squared is 9. And so how many times does 9 go into 24? We've already done that right here, 2 times, right? And so we know that instead of being 2 places, a 2-digit number, our base 3 is going to be a 3-digit number because our 3 squared goes into 24. And so how many 3 squareds do I have? Well, I got 2 of them. Now I have 6 left over, and since I have 6 left over, well, how many 3s go into 6? Well, there are 2 3s in 6. And so how many 1s do I have left over? 0. And so 220, or 220 base 3 is equivalent to 24 base 10. So that's how you go through and do it. So if you want to convert 100 to base 7, you could try to do this on your own. So it'd be good to try this on your own. You think about, well, how many 7s go into 100? Well, if you wanted to, you could start by dividing by 7, but I think it's easier to think about the powers of 7. Well, the next power of 7 is 49. The one after that is actually 243, which would be, it's definitely more than 100. So how many 49s go into 100? Well, there are 2. And so that leaves you with a remainder 2. And so if you think about this, your place, this is the 1s, this is the 7s, this is the 49s. So how many 49s do I have? I have 2. Now how many 7s go into 2? Well, none do. But you got to make sure you put that 0 in there. If you forget that 0, that's a big problem. And then how many 1s do I have? Well, I've got 2. So 100 is equivalent to 202 base 7. So 100 base 10 is equivalent to 202 base 7. Okay, so our next problems ask you to convert 46 base 3 to base 8. There are a couple ways to do it, but the way we're going to do it is we're going to just do basically the problem we just did, which is convert to base 10 and then convert to base 8. So 43 base 6, well, remember this is going to be the 1s, this is going to be this how many 6s, and so you got 4 6s and 3 1s. And so that gives you 24 plus 3, which would be 27. So 43 base 6 is the same as 27 base 10. That's just like the problem we did in the last video. If you want to convert to base 8, well, what's the highest power of 8 that goes into 27? Well, just 8 to the first, right? Because 8 squared is 64, which doesn't go into 27. So how many 8s do I have? Well, you're going to have 3 8s inside 27 with a remainder of 3 1s. So your answer is going to be, remember, this is 8s. This is 1s. So you got 3 8s, 3 ones, and so 43 base 6 is equivalent to 33 base 8. Convert 3124 base 4 to base 9. Well, you got to convert it to base 10 first. There's 4 numbers. Remember, this is the 1s, the 4s, the 16s, 64s. These are just the powers of 4. 4 to the 0, 4 to the 1st, 4 to the 2nd, 4 to the 3rd. I've got 4 1s. I've got 2 4s, which represents 8. I got 1 16, and then I got 3 64s, and 64 times 3 is 192. So if I add those together, I'm going to get 220. So I've got 3124 base 4 is the same as 220 base 10. Now I want to convert that to base 9, so I've got to think about powers of 9 that go into 220. Well, obviously 9 does, but what's the next power of 9? 81. So 2 to the 2nd is 81. And so when we think about 9s, we start with 1s, 9s, and 81st. The next things would actually be 729s. Well, are there going to be any 729s in 220? No. So I don't have to consider that. So how many 81s are in 220? Well, I think there's going to be 2. And so that gives me 162, which would give me 8. So a remainder of 58. So we know there are 2 81s. How many 9s go into 58? Well, there are 6 9s that are going to go into 58. So that gives you a remainder 4. So you got 6 9s and 4 1s. So 3124 base 4 is equal to 264 base 9. So when you're converting from one uncommon base to another uncommon base, then you convert it to base. One easy way to do it is to convert to base 10 first, and then convert back to the base that you know how to do. So you'll see some problems like these on your lesson worksheet, plus review problems. Make sure you work all those, and please email me with any questions you might have.